All right, hello people, this is being recorded for, this is section 8.3. We will get done with these notes today. This is not too tough of a concept. This is using statistical experiments, like data that has been collected already, and we're just making calculations with them, okay? One of the first thing it has us do is calculate a mean, which means like an average. And we have a population mean, and the symbol that they use for mean is this little symbol right here. It's like a cursive U. This is the mean, but it's a Greek symbol. If you want to see like it actually typed out, it looks like this. It is called mu because it looks like an M and a mu, an M and a mu together. So it is called mu. Mu is his name, and he is the symbol that we use to represent the population average, okay? So here's the deal. We find an average. Gabe just said add them all up and divide by the number of numbers, right? But I'm going to do something different up here. I'm going to create a new example at the top, and we're going to do a weighted mean. W-E-I-G-H-T-E-D mean, okay? Because a weighted mean is not just adding them up and dividing by the number of numbers. It's a little bit more difficult, okay? So let me give you an example here. What? No. Put it down. You can text her in a minute, okay? Weighted mean. All right, here we go. In this class, if you didn't realize this already, here you go. In this class, you have test grades, you have quiz grades, and you have homework grades, okay? So I'm going to give you some examples on how this works and how we figure out your overall average. Let's say that for quarter 3, you only had 2 tests. I don't know how many tests you had, maybe 3, but we're going to say you had 2, and we're going to say that they were 85 and a 95, okay? We're going to just do that, okay? Just write these down. You had 2 quizzes, 2 mid-chapter quizzes. We're going to say that they were, let's go a 90 and a 100. Let's say you had a quiz that was a 90 and a quiz that was 100, okay? And let's say you have 5 homework grades. You have way more than that, but let's just do 5 for right now. And let's say you got a 90, a 94, a 94, and then 2 100s. We'll go 2 100s, okay?
We can't do such high grades all the time.
I know. So these are obviously not, I don't know, Isaac's grades or something, you know? I'm just kidding. Okay? All right, so here we go. I know. All right, so within each of these categories, you have an average. Like if I average your test grades together, like adding those 2 grades up and dividing by 2, or finding the exact middle. What's the middle of 85 and 95? Or the average is a 90, right? So your average test grade will be a 90, right? Okay. Your quiz grade, what's the average quiz grade you will have? 95. That's exactly in the middle, right? If I add those 5 together and divide by 5, it's like 95.6 or something like that. Somebody want to check me? 95.6.
It'd be 95.6.
95.6. Okay, now, just because 95.6 is the average of those 5. Let's say that we had a 6th homework grade in there that you didn't turn in just for fun. And let's say we had a 6th grade that was a 0, right? Okay, somebody else want to add those together and divide by 6 now and see what our grade goes from?
It was much lower.
95.6 goes down to, I'm trying to get a point across to, yes.
79.
Trying to get a point across.
79.6. 10. You see what it does to your homework grade? Woo! 10. We'll plummet it that much. Now, that's when they only have 6 grades in there. So if you have like 15 grades and you have 10, it's going to do less than that. But it does affect it a lot. Okay? No. We're not gonna play that game. All right. Nope, we're not gonna play that game. All right. So these are each one of your averages according to the category. So if I was trying to find your overall grade, if they were all weighted the same.
Reese and Josie in there.
Yes, they are.
Could they come to the office, please?
Yes,
They're
they
gonna be
can.
helping Mrs. Stark.
Yep, that's fine.
Thank you.
Okay, if these three categories were all weighted the same, we would add them together and divide by 3, but that is not how it works in math class. Which category is weighted the most? Of course it is, right? So tests are 50% of your grade, so I'm going to write 50% next year. How much is a quiz worth?
25.
25%. How much is homework worth?
25.
25%, which makes 100% total. So those are my 3 categories, but tests are weighted the most. All right, now, if I'm going to, given those weights, calculate your average, how do you do it?
Oh my god, I messed up my
So,
Okay.
You do 90 times 50 for
We take 90, but we take it times, I'm going to take it times 0.5 because 50% as a decimal is 0.5, right? I'm going to add that to 95 times point, what?
25.
25, because that's 25% of your grade, plus 95.6 times another 25%, okay? And then we divide, but we have to divide by 100%, and 100% as a decimal is what?
1.
Just 1. So we really don't have to divide by anything by doing that, yeah? Okay? Somebody help me out here. Take 90 times 0.5 plus 95 times 0.5 plus, what is it?
oh, this calculator just showed up in front of my face.
Oh, okay, 40 plus 23.75. This should be 45. What?
23.9.
I don't know. Somebody add it all together, would you?
92.65.
92.7. 92.7%. Now, here's the deal, though. Look at that 92.7%, and let's compare it to the 3 grades, right? Okay? We had a 90, a 95, and a 95.6. If these were all averaged the same, right, I'm guessing that our average would be like right at 95 or maybe like a 94 or something, but that 90 is the category that's weighted the most. So it's pulling your average down to a 92.7. Does that make sense? Right? Rather than it being a 94, which is what it probably would be if you weighed them all 3 the same, that 90 is pulling it down. Okay? All right, so this is what your mu is, your average. Your mu, that's the symbol that we use for the population average. Good? Happy with that? Now we have something else called a population proportion. Circle that word. We use that and call it P, and P is the proportion. And a proportion is kind of another way of saying a percent. Okay? Proportion is kind of like percentage. So we use that also. Rather than a mean, we use a percentage or a proportion. And that's what we're going to be doing for some of these other ones down below. Okay? So just hold on to that. P and mu. Those are the ones that we're dealing with. All right? Let's go down to this one right here. And example 1. There are 51 residents in a dorm. This total is 51, if you want to mark that table there. We have 51 students in a dorm, and they were taking a certain number of classes. So there were 6 students that were taking 1 class. There were 5 students that were taking 2 classes. 26, or the majority of students, were taking 3 classes, etc., right? Then we have 3 students that are like going above and beyond and taking 5 classes. They're really filling their schedule, right? So we want to know the average number that these kids are taking, right? Like the average number of classes. Now, I can't just get away with taking 1 plus 2 plus 3 plus 4 plus 5 and dividing by 5. I can't just do that, right? Because one of the categories is weighted really heavy and the other categories are maybe not weighted so much, right? Okay, so we're going to figure out what this average is, okay? Now, I asked the 6th period class how to do this. What do you think?
6 times 51.
There are 6 ones, which means there is a 1 6 times. Don't write this down. 1 plus 1 plus 1 plus 1 plus 1 plus 1. There's 6 ones. There are 5 twos, so 2 plus 2 plus 2 plus 2 plus 2. There are 26 threes. 3 plus blah, blah, blah. That's going to take forever, right? What can we do instead?
3 to the 26 power.
No, not power. There are 6 ones, so 1 times 6. There are 5 twos. Write this part down. 2 times 5 plus 3 times 26 plus 4 times 11 plus
5 times 3.
5 times 3. And then we have to divide all that by
1. Oh, wait.
That was when it was percentages. These all inside here, the weights all add up not to be 1. They add up to be 51. So we're going to divide that. Okay. If you add it all up together, you get 153 divided by 51. 3. Which is kind of boring because 3 is like right in the middle anyway. But it won't always be the case normally when you do a weighted average, you're going to end up with a decimal, and be prepared for that. Okay. All right. So this question down here, what does the population mean for the number of classes taken this semester? What's the average number of classes taken this semester? 3 hours. 3 credit hours. Okay, is what mu is. Mu is 3. Okay, now we're going to get a little bit easier before we get a little bit harder. Ready? On the back side, we're going to talk about proportions. So in a population of 250 people, 90 of those people said that they prefer running versus hiking. What is the proportion of people who prefer running over hiking? 90 out of 250. 90 people out of the 250 people prefer running over hiking. What is that as a decimal?
About
90 divided by 250. 0.36. That is my proportion. 0.36. Now it says, what percent of the population prefers running over hiking? 36%. If we just convert that to a decimal, we move the decimal 2 places, and it's 36%. That's pretty easy, right? We can do that. That's not too hard. Okay. All right. Ready? Okay. There are 2, 4, 6, 8, 9 of us in this class, including me, right? Okay. 9 in this class. And I'm going to give you an example over here. We're going to talk about blue-eyed people. Okay. So over here in this box, we're going to talk blue eyes. Okay. Out of the 9 people in this class, raise your hand if you have blue eyes. I am not counted in this.
I'm not actually sure. Wait.
Blue eyes. Blue eyes. Do you have blue eyes?
Change?
I don't know.
Mine do too, but
Yours aren't blue.
mine's
Mine
mostly.
was
You're gone.
We got a
Your eyes-
blue. We got a
your
blue.
eyes
We got 2
changed from,
blues.
like,
Anybody else? Blue eyes? Blue eyes? Are you blue? Are you blue?
No.
No?
I got blue eyes,
What if
mine.
Do you have? Does he have blue eyes? Does he have blue eyes?
Eyes?
You guys don't know what color eyes you have? Come on.
Hey,
He
Me and
has,
my
he has
parents-
bluish green eyes, so just give him blue.
Mine are the same. Mine are blue.
Because his are like mine. His are like mine.
Mine changed between
All right.
blue and green.
I don't just look
All right,
at
we'll
my
count
eyes.
you as blue then. We'll say 4. 4 blue eyes. 4 out of 9. All right, here we go. Write this down off to the side. 4 out of 9 people have blue eyes, yeah?
That's actually pretty
In
good.
this class. Yep. 4 out of 9 people in this class have blue eyes. That was the same actually as what we had 6th period. We had 4 out of 9, so that's kind of exciting. 4 out of 9 have blue eyes. Write that down off to the side. So the proportion of blue-eyed people is 4 over 9. Do you know what that is as a decimal?
About point.
You know your 9s?
0.4 repeated.
0.4 repeating. So that is 44%. Okay? 44% in this class have blue eyes. Now, here's the important part. Are you listening to this? If I want to survey all of the people in Blue Hill and see what percent of them have blue eyes, it's not really fair for me to say that 44% of all of the students in Blue Hill have blue eyes, right? 44% was for this class, but it might be like closer to 40%, or it might be closer to like 48% or something like that, right? It might be different than 44% exactly, okay? And the reason why is because we have a margin of error, okay? So circle the word margin of error. Because I only surveyed 9 of us in here,
We can't really make it.
we can't say that it's exactly 44%. So we calculate what's called a margin of error. I could be off by a certain amount because I only surveyed 9 of us, right? So the way to calculate a margin of error, I'm going to rewrite this a little bit bigger, write it off to the side. The margin of error is plus minus, don't worry about the plus minus for right now. I'll explain what that means here in a second. 1 over the square root of n times 100. Now, what do you think n stands for?
Number.
The number of what?
People
Things.
surveyed.
The number that you surveyed, right? The number of people that we surveyed.
Familiar equation.
Yep, the number that we survey. Okay, so according to our group, we only surveyed 9. So here's the deal. We're going to calculate our margin of error. We're going to say plus minus 1 over the square root of 9 times 100, right? What's the square root of 9?
3.
3. What's a third of 100?
1.
Is 33%. 33 and a third. We'll just say 33%, okay? That is a really big error. That's a really big error. Here's what that's saying. We said 44% had blue eyes in this class. But my error is 33%. So we add the 33% and we subtract the 33% to get, what's 44 minus 33%? 11%. And what's 44 plus 33? 77%. So, here's how this works. According to our class, we had 44% have blue eyes. If I would use that to say about the entire population of Blue Hill students, I would tell you that somewhere between 11% and 77% have blue eyes. And you're like, well, that doesn't narrow it down very much, right? That's not very accurate at all. So what do I do to make it more accurate? Survey more people, because here's what happens. Your margin of error, the error goes down the more you survey. Hold on.
If you survey everybody that you're looking at,
Then that means there's no error, right? Because your population would be the same as your sample.
Oh, what if you did it wrong though?
Maybe, yeah, maybe
What?
then. Maybe
That's
then.
an
Okay.
error.
What
That'd
if,
be biased to-
so what would you call it though? If it was really unlikely, but it happened, so like your error was like 70%, and you didn't survey that many people, but then you survey everyone, and it actually happened.
Yeah, John, all you gotta
I don't
do is
know.
look at them.
I don't know. If you surveyed everybody, you wouldn't need to do an error because you would have the correct number. Right? Okay, so your error goes down the more people you survey. Let's look at this example that they have. So a survey is conducted to determine how many people will vote for the school presidential candidacy. The results of the 500 students. Now, what does 500 stand for? What variable do we use? What variable do we use for that? 500 is N. Caitlin said N is 500, okay? And according to the survey that we did, 62% said that they would vote for candidate B, okay? But 500 people is not the entire school according to this, right? Like they didn't survey everybody in the entire school. So we need to calculate the margin of error, okay? Margin of error is plus minus 1 over the square root of N. So we do the square root of 500, and then we do times 100, okay? Do 1 divided by the square root of 500 and then take that.
22.36.
What did you get?
22.36.
I don't think that's right.
Yeah, that's right. The square root of 500?
1 divided by the square root of 500. 1 divided by the square root of 500.
Hold on.
They have the same?
I think it's like 4.5%.
0.002.
Yeah. It should end up being, after you take it times 100 then.
It's 0.04.
Okay, now take it times 100. 4.5% is what your error should be, right? So plus minus 4.5%, okay? So this is my error. When they ask for error, that's what it is. We could be off by 4.5% maybe, right? Okay, so what that means, according to the 62%, is that we can't say that exactly 52% or 62% are going to vote for a certain candidate. We can say somewhere between 57.5 and 66.5. That would be adding and subtracting the error. Somewhere between those two percentages are going to vote that way, right? What? Yes. Now, this group, this was a lot closer together than what we had for the blue eyes. Why?
Because there's more that we're surveying.
We surveyed more people, so we are more accurate, right? Yes? Makes sense? Okay? Can you wait just a second? We're almost done. Okay. All right, last one. Using the margin of error to find the sample size. So here's what's happening. Ready? Okay. Over here we have this equation for margin of error, and instead of working that equation, they're wanting us to solve for n, and they're giving me this. Okay. So here's what we're going to do really quick. We're going to take this formula and we're going to rearrange it so that n is on the one side, right? You remember when we did like solving for and getting y by itself, right? We're going to do the same thing, but we're going to get n by itself. So here we go. I'm going to ignore the plus and minus for now. We're going to say E equals. Don't write this down until the very end. Okay, I'll do the work for you, but tell me what to do. Okay, don't write this down yet. I'll give you the formula and I'll tell you when you're going to write it down. We need to get n by itself. So what would you like to move first? Let's divide by 100. Okay, E divided by 100. There's that. Okay, so I have, don't write this down. Don't write this down. E over 100 equals 1 over the square root of n. Now what would you like to do? Times the square root of n. Okay, that's gone now. Times the square root of n. That doesn't mean don't listen. Still listen. Okay. All right, equals 1, right? Now what would you like to do? What? I want to get n by itself. Let's divide this guy over. So we're going to divide 1 divided by e over 100. That equals the square root of n. Okay, now, if we're dividing by a fraction, like 1 divided by e over 100, what can we do with that? If you're dividing by a fraction, multiply by
On top.
if we're dividing by a fraction, we multiply by the, we keep, flip. We're multiplying by the reciprocal. So we're going to flip it to 100 over e now instead. What's 1 times 100 over e?
100 over E.
100 over e, right? Okay. Now, last step, e. What do I do to get n by itself?
Square root.
How do I get rid of a square root? Square it. So I'm going to take this guy and square it. So this is what you need to write down. Once we rearrange and we solve for n is going to be 100 over e squared. This is what you need to write down. That's what you need to write down. N is 100 over e squared. Okay? All right. Now, here's the deal. Example 4 says, use the margin of error to find the sample size. So you are a member of a research team and you are going to run a simulation. The simulation needs to result in an adequate sample size and a margin of error for each trial. Find the sample size, so we're solving for n. N is what we don't know. That you should use in order to have a margin of error of 3%. Okay, now, let's compare. Up here, we had a margin of error of 4.5%. How many people did we survey when we had a 4.5% error? 500, right? 500 people we surveyed for 4.5%. Now, wait a second. We want to have less of an error. We want to go from 4.5% error to a 3% error. So, are we going to have to survey more than 300 or less than 300? More, because we need to be more accurate, right? So, we're going to end up with more than 500. More than 500 people. Okay, so we're going to use the formula that we just wrote down. N equals 100 over E squared to find my number of people that I need to survey. Okay, 3% is just going to go in for E, so I just put 3 in this spot. Don't convert it to a decimal. That's what the 100 does for you. Okay, 100 divided by 3, and then you square that. How many people do we have to survey? It's something like 111.1.
It's 1,111.1 repeating.
Right. Okay. So now we have a debate. Here we go. 1,111 people. That we can't have 0.1 of a person, and I don't care if they're missing body parts or whatever. You know, that's still a person, right? 1,111 people, right? If it rounds to the nearest whole person, it would be 1,111, right? But if I surveyed 1,111 people, do you know what my error would be?
It'd be over.
It would be like 3.001% error, right? But I don't want it to be 3.01. I want less than 3% error, right? So 1,112 people, which is going to give me an error that's probably like 2.999% error, but
It's less than
it
3.
ends up being less than 3%. So we're always going to round up to the nearest person, and I'm going to survey 1,112 people. So put a little star that says always round up. And that is a lot of people to survey, but you have to decide, is it worth being more accurate to survey more people, or it depends on what we're surveying. So in this next problem, Reese, we say that we're going to allow our error to be 10%. Maybe it's something that doesn't really matter, right? Doesn't really matter that much, so we can be off by a little ways. We're going to give it 10% error, right? How many people do we have to survey?
Less than 500.
Less than 500, right? 500 was a 4.5% error, right? So let's see how many people we have to survey if we want a 10% error. We're going to do that same formula again right here. 100 divided by E, and we're going to square it, okay? We're going to plug in, We're going to plug in 10%, or 10 in there for E. What's 100 divided by 10 squared? 10. 10 squared is?
100.
100. So we have to survey still 100 people, and that's a 10% error. That's a pretty big error, right? That's a pretty big error yet.
How is there that big of a change in between the 500 people and the 1,000 people.
You're looking at like this number versus this number versus this number.
Yeah.
You went from 3% to 4.5% now to 10%. I don't know. I don't know.
It's just the way it is.
Yep, that's just the way that it works. That's just the way that it works. Okay, so that's kind of how, like if you want your error to be low, you have to survey more people, right? And if you don't care about your error being a little bit higher, you can do less work and you can survey less people. That's the way that it works, right? Okay, so on your homework assignment, you're going to do the evens both sides. It is not hard. It's really speedy quick, actually. Okay, use your time to work. You've got lots of time. Use your time to work. You can do it. Evens on both sides. Evens on both sides. Okay, questions before I shut the video off?
Nope.
All right, there you go. Goodbye, people in the video.